Good. What I'm presenting here is a lot of manual work from Lionel Kush and a little bit of work from me and Sandra. And it's about, again, a co-simulation workflow of TVB-NEST and Elephant. And last week we had our first alpha release. I need to click on a different screen. I'm terribly sorry. I'm not sharing my correct screen.
Okay, now this is your presentation.
Good, that's good. Last week we had the alpha release of our software done by Lionel, a lot of hard work that shows this working. It's deployed using a Singularity container, or obviously you can install it yourself. And we have information available on the Colab version 1 and 2, and all the software is downloadable from GitHub. This work goes a little bit back to the basic fundamental problem that co-simulation tries to solve, and that is that you have the virtual brain on the one side, which simulates neural mass models, so it's a scale that speaks in neural mass dynamics, and looking on the left, you're looking at NEST, which speaks in spikes. And there's a fundamental mismatch between these two scales and these two languages. And to solve this problem, we tried to focus on the problem of translating between these different scales. So we added in this whole concept of two simulators, two translators, in the two directions that you have. And what we did is to not run this on a single node, but to run these different components on a different node of the supercomputer, because we do not yet know how much performance is needed for each of this individual step. It might be that translation between NEST and TVB takes up 20 compute nodes if you want to do it at scale. And the other way around is the same problem. So what you see here is that these four applications are isolated in their functionality and also run in isolation on a supercomputer node, and then communicate with each other using HPC transport methodologies. I'm showing here the four blue boxes, and on this slide, you might see in the right bottom the same four boxes again, where we have on the left NEST, that transports spikes, and then Elephant that translates this into rates. This goes to TVB, and the rates go back to NEST. I'm showing this complicated picture because it also shows you where we're going with this whole framework, because NEST and TVB are just two of the different simulators that we have in eBrains. We have a lot more tools available. We have Arbor, we have Neuron, we have Gazebo, which is the neuromorphic system. So this system has a number of use cases, which include co-simulation of TVB with Arbor, TVB with NEST, TVB with the neurorobotics platform. So this is where we're going. Here in red on this page, everything that is now implemented by Lionel. Here in red, everything that is currently in production or exists as a proof of concept. And in blue, we're even working on the generation of LFPi and bolt signals from Arbor simulations. So this is all on the way or exists at the moment. We do this because we want to have a very strict separation of concerns of science and software. Why the science? Because these translation modules are where all the magic needs to happen. We do not know how to translate from NEST to TVB or the other way around. And a lot of this is the challenge of our group, that we now need to find out how to do this translation between these scales. And by isolating this in a dedicated application, you can scale this. You can make an interface so that it is very usable for the end user. And then on the software level, this loosely coupled infrastructure allows you to have less dependencies. Versioning becomes easier. Synchronization issues become easier. And parallelization becomes easier because inherently this setup is parallel. You can do compute and communication at the same time. It's HPC ready. The individual components, we could scale it up and down dependent on the need. And we can do this because we're using spikes as a communication backbone, where we only talk spikes between the different simulators because that's the inherent natural language of the brain. And this will allow not TVB to NEST simulation, but TVB to X simulation. Arbor, neurorobotics platform, the neuron simulator, even neuromorphic computing is something that we're targeting. And then step 2, a lot of this infrastructure is shared, which means that if all the different simulators use the same tools, it becomes a lot cheaper. Cheaper in this case means a lot less manpower to support this functionality. This is not work from me or Lionel in isolation. We have a large group of multi-scale developers, and we also have a set of more senior scientists that steer us in the direction that we want to go. And here are the email address of me and Lionel. Thank you.